Hi, in this video, we will discuss how we can apply determinants to solve systems of linear equations using Cramer's rule. Cramer's rule is a formula that uses determinants to solve a system of n linear equations in n variables. This rule can be applied only to systems of linear equations that have unique solutions. To solve systems of linear equations using Cramer's rule, let's consider example 4.8. Solve the systems of linear equations using Cramer's rule. 12x plus 3y is equal to 15 and 2x minus 3y is equal to 13. The first step is to create a matrix using the coefficients of our variables x and y. That is 12, 3 for the first equation and 2, negative 3 for our second equation. Using this matrix, we compute the determinant of the coefficient denoted by D, which is equal to 12 times negative 3 minus 2 times 3. Performing the operation, we get negative 42 as our answer. Next, we get the determinant of x, denoted by D sub x, by creating a new matrix using the first matrix, but replacing the coefficients of x with the constants of the system of linear equation, giving us 15 and 13 for the first column, and 3, negative 3 for the second column. Finding the determinant of this matrix, we have D sub x, which is equal to 15 times negative 3 minus 3 times 13. Performing the operation, we get negative 84 as our answer. And the third step, we get the determinant of y, denoted by D sub y, by creating a new matrix using the first matrix but replacing the coefficients of y with the constants of our system of linear equation, giving us 12 and 2 for our first column. So we just copy this, and 15 and 13 as our second column. Finding the determinant of this matrix, we have D sub y is equal to 12 times 13 minus 2 times 15, which is equal to 126. Finally, we identify the solution of the system by using the following formula. For x, we have D sub x over D, whereas for y, it is D sub y divided by D. Solving the value of x, we have D sub x is equal to negative 84, whereas our D is equal to negative 42, giving us 2 as our answer. And for y, we have 126 divided by negative 42, which is equal to negative 3. Therefore, the solution of the system of linear equation is 2, negative 3. Let's consider another example, which is given here. Solve the systems of linear equations using Cramer's rule, and the system of linear equation is x plus y minus z is equal to 6, 3x minus 2y plus z is equal to negative 5, x plus 3y minus 2z is equal to 14. So the first step is to create a matrix using the coefficients of our variables, that is 1, 1, and negative 1, 3, -2, and 1. And for our last row, that is 1, 3, and -2. Next, we calculate the determinant of this matrix using the shortcut method. That is, here, we multiply these values, and this value, and this value. So for this, 1 times -2 times -2 is positive 4. 1 times 1 times 1 is 1. -1 times 3 times 3 is -9. We get the product of this, and this. And that is 1 times -2 times -1 is positive 2. 3 times 1 times 1 is 3. And -2 times 3 times 1 is -6. Therefore, the determinant of this matrix is equal to D is equal to 4 plus 1 plus -9 minus 2 minus 3 minus -6, and this is equal to -3. Next, we compute the determinant of X denoted by D sub X by creating a new matrix from the first matrix and replacing the first column, which is the coefficients of X, by the coefficients of the system, giving us this matrix, that is 6, -5, and 14 as our first column. So these are the constants of our equations. We copy the second column, that is 1, -2, 3, and -1, 1, -2. Calculating the determinant of this 3 by 3 matrix, we use the shortcut method. So we multiply this, and this. So this is equal to 6 times -2 times -2. That is positive 24. 1 times 1 times 14 is positive 14. And this one is -1 times -5 times 3. That's positive 15. Here you multiply this value, and these values. So we get 4 times -2 times -1. That's positive 28. 3 times 1 times 6. That's positive 18. And -2 times -5 times 1 is positive 10. Computing the determinant denoted by D sub X, that is 24 plus 14 plus 15 minus 28 minus 18 minus 10. And this is equal to -3. Next, we compute the determinant of Y denoted by D sub Y by creating a new matrix from the first matrix and replacing the second column, which is the coefficients of Y, by the coefficients of the system, giving us the matrix 1, 3, 1, 6, -5, 14, -1, 1, and -2. Then, calculating the determinant of the matrix, we multiply this, and this. So this gives us positive 10. This is positive 6. And this one is negative. And this is -42. And we have this, and this. So this gives us positive 5. This is positive 14. And this one gives us negative 36. Then we compute D sub Y, which is equal to 10 plus 6 plus -42 minus 5 minus 14 minus -36. And this gives us negative 9 as an answer. Then we compute the determinant of Z, denoted by D sub Z, by creating a new matrix from the first matrix and replacing the third column, which is the coefficients of Z, by the coefficients of the system, giving us 1, 3, 1, 1, negative 2, 3, and 6, negative 5, and 14. Then we compute the determinant. So we multiply this, this, and this. This one gives us negative 28. This one is negative 5. And this one gives us 54. Then we multiply this, this, and this, which gives us negative 12. This one is negative 15. And this one is 42. Therefore, the determinant of this, denoted by D sub Z, is equal to negative 28 plus negative 5 plus 54 minus negative 12 minus negative 15 minus 42, which is equal to 6. Finally, we compute the solution of the system using the formula x is equal to d sub x over d, y is equal to d sub y over d, and z is equal to d sub z over d. So for x, we have a negative 3 over negative 3. So this is equal to positive 1. For y, we have negative 9 over negative 3, which is equal to positive 3. And for z, we have 6 over negative 3, which is equal to negative 2. Therefore, the solution is 1, 3, negative 2. To solve systems of linear equations with 4, 5, 6, and so on number of variables and number of equations, we continue the pattern presented in this video. Thank you very much for watching, and I hope you learned something. Have a great day.